Welcome to the recap session for part 1 of Lab 3 for the Unity 1 course through the Johns Hopkins APL STEM Academy program. This is going to be a review session for the students who are in the class. If you've somehow stumbled across this, it's good information anyway and you'll be able to get through it, but it's also loosely based on the Unity Create with Code curriculum. So if you're looking up additional information, or if you're one of my students who wants more review on some of these topics, that would be a good place to look. The basics of what this lab is going to be is just the core mechanics for an infinite runner. This is the last lab going into the final project, so we're not building out a full thing. We're not going to worry about models. All we're going to do is just learn some of the basic controls and components that you're going to want to know going into final projects. In this case, the first thing we want to do is we want to add a more realistic jump. In the past labs, what we did is we used translation to handle movement of a player. But in this case with a jump, we don't really want to instantaneously move from one point to another. So what we're going to be doing is covering how to apply forces to an object to get it to behave in a more physicsy way, the way a player would or a person would if they were to jump in the real world. The other thing we'll cover is a little bit about what tags are and how tags can help you identify what objects you're interacting with when you collide with them. Detecting in your script what you're interacting with. So let's go ahead and get started. Now you can see what we have here. It's just a very basic, very boring. I made a floor, and on that floor there's a cube, just a red cube to make it nice and visible. That's going to be our player in this scenario. So the first thing we're looking to do is have controls to make the player jump. And similar to the fashion that we've done it multiple times in the first two labs, I'm going to go ahead and make a folder for my scripts. And in my scripts folder, I'm going to create a new C# script. And I'm just going to call it player controller. Somewhere to contain all the controls for our cube and how to make it move. Some of the students early in the semester had issues with not autofilling when it opens a Visual Studio. You can double click on the script. It usually works, but sometimes if you go to this open C# project, it saves you a bit of a headache because it will correctly open the whole project and then know how to autofill things for you. So small tip while we're at it. So here's our script. We got it open. As usual, it's got the two methods that are autofilled for us, start and update, to run at the beginning of execution of the scene and to run every frame to control our player. Now before, what we've done is if we wanted to make our player go up, we would use something like transform.translate an up vector and multiply it by some amount we want it to move. But as mentioned, in this case, we don't want to just move it from place to place. We want to actually add a force to it to get it to jump realistically. And one thing we know we're going to want to do is we need to have some input to tell it when to jump. And I'm going to go ahead and make a public instance variable of type keycode for a jump key. And as we've seen before, if I hop back over to Unity here, here's our cube. I'm just going to rename them to be the player. And we're going to give this player the player controller script. One other thing we know we're going to want them to have is a rigid body, because right now if I run the game, you'll notice my game window down here, nothing happens at all. I at least want them to fall if they're already in the air. So let's go ahead and add a rigid body. There it is. And now if I run it, falls to the ground. Super exciting. But we know our player also has this player controller script. Let me minimize some things so you can actually see this. And it's now got the jump key here, the way it does when you give it a public instance variable so that we can access it from Unity. And if I use this drop down here, I can select, let's use the space key. Pretty common for jumping. Now that we've got that, we can come into update and check if input get key down, in this case, because we want to detect when it's first pressed down, not if it's being held. We want it to only go down in the first frame it was pressed. So if our jump key is being pressed, we want to jump. And to jump, we need to apply a force. Well, how do we do that? Previously, we used transform to handle our movement. And if you come look over in Unity, keep in mind that every game object has a transform, something that defines its position in the world. Not every game object has a rigid body. So by default, the way that the code is written in Unity, it doesn't know that this rigid body exists, and we're going to have to search for it and find it. So somehow we have to get access to this rigid body, because the rigid body component is what handles all of the physics. So the rigid body component is what's going to have methods that let us add a force to something. Well, components are more than just a component. Like all of the scripts we write, behind the scenes, they are a C# class. They're a C# script. And so, in this case, let's make it private because we don't need to drag and drop it the way we would, or type in values or alter it. Generally, best practice, you want to make things private whenever they can be private. And in this case, we know we're always going to get the same rigid body. It's the one attached to this object. So like I mentioned, because it's actually a C# class, rigid body is a data type. So we can define a private variable of type rigid body, and let's just call it RB. So now we have a rigid body variable, but there's nothing currently assigned to it. We've declared it, but we haven't initialized it. And the best place to do that is going to be inside of our start method. We only need to get it once. There's no reason we need to go every single frame and find our rigid body again. Let's find it once and save it in our instance variable. And to do that, there is a method. So RB equals GetComponent. And then in these angle brackets, this is something that you probably don't need to worry about too much now. It's a thing called generics that some programming languages have. It defines what data type it returns. Don't worry about it too much. Long story short, we're going to tell it what type of object we want it to find. So this is going to get the rigid body component belonging to this game object. And then it takes no arguments, and that should do it. So now what we've done is we've located our rigid body using this getComponent method that exists on a game object. We've told it the type of script that we want to retrieve, or the type of component that we're looking for. We're looking for a rigid body, which matches the type of this instance variable. So that should be happy. And we've saved it. Which means now we'll be able to interact with this down here. And rigid bodies have a method called addForce, which sounds exactly like we want it to do. And if I look at some of the autofills here, it's got a couple different arguments. One of them just takes a vector 3. That seems pretty straightforward. This is the other one we're going to look at because it's kind of interesting. It's vector 3 and a force mode. We're going to want to use that, and I'll point that out in a second. But in this case, all we want to do is add a force up. But the up isn't necessarily going to give us enough information. These shortcuts, like vector3.up, has a magnitude of 1, and we don't know if that's going to be the amount that we want it to be. So let's make another public instance variable so we can kind of play around with how strong this force is a little bit from inside of Unity without having to edit our code. So if I make another public variable of type float, we want to be able to give it a decimal number. So if we want it to be twice as strong, we'd make it 2. If we want to make it half as strong of a jump, we'd make it 0.5. And we can call this one jump force. Nice descriptive name. And then down here, multiply it by the jump force. So jumping back over to Unity, we can see we now have jump force on our script here. It's got a magnitude of 0. That's not going to be what we want. I'm going to make this relatively high right now. We'll see why in just a second. Okay, we're getting a very, very small jump, so even 100 isn't high enough. Let's make it 500. And there we go. We got a jump. So the reason that number had to be so high, coming back over here, I mentioned before that there was a different form of this method that takes in something called a force mode. And a force mode is just a list of different options of what type of force we want to apply. So I can type force mode dot, and you can see here I've got several options: acceleration, force, impulse, velocity change. It gives you a description if you hover over these, but effectively what's happening by default is it's using the acceleration mode of a force, which if you're familiar with physics, if you've taken an introductory physics course at any point, acceleration is going to have to do with the force applied over a period of time. So the issue that we're having that causes us to need this number to be so large is that it's actually multiplying it by the fraction of a second that's elapsed since the last frame. So a force of 100 is actually going to be 100 times 1/60th if our game is running at 60 frames per second. In this case, we want to use impulse. Not that it really matters. You can make it really, really massive, but kind of a cool thing about Unity is that when it's doing all these calculations, it's actually doing them in scientific standard units. So 1 unit of distance in the game world is equal to 1 meter. Acceleration uses seconds. It's actually in newtons if you apply a force. So it all works out if you were to do physics simulations. And because of that, we want to just explicitly say we're giving it an impulse because we want an instantaneous application of force, not a force applied over time. Little bit of a tangent there, but kind of a cool thing to know, that it all works based on actual physics units. You'll see that with gravity in a second here. So now that we've added that to impulse, I bet if we come back over here and run this, it's going to jump way too high because it's going to be 60 times stronger of a force if we're running at 60 FPS. In fact, we still haven't come back down. It's coming down now. And there it is, straight through the floor. So we can make that a little smaller now. Let's make that force 10. It's not a bad jump. We can even make that more like 8. 8 seems pretty reasonable. So we're going to go with 8 for the purposes of our game. There it is. And this is another case where, as I mentioned before, probably a good idea, once you know what you want that value to be, come back over here and make that force a private variable and just assign it in here. Because that way you don't ever have to worry about accidentally altering it in the Unity UI. But we'll make it public for now, just for test purposes. Because another cool thing to see is, like I mentioned, because Rigid Body does all those simulations, not only do we have a force of 8, now we can also kind of play with the mass. So if I make this a mass of 10, and then I try to run it again, that jump force of 8 is going to do almost nothing because the object is way heavier than it used to be, so it takes a much bigger force to give it a push. So you can play around with the balance of those to get some movement you like. Another good thing to know is that if you go to Edit, if you're on a Windows machine, and open your project settings, there's this physics tab here. And the physics tab gives you a lot of useful parameters you can alter, including gravity. And once again, if you've taken intro physics, this negative 9.81 might be very familiar to you because that's the acceleration due to gravity. So if I were to make that negative 18, I'd have twice as strong of gravity. Or if we really want to have some fun with it, if I make it 1, now our gravity is actually going to point up. So if I run the game, we should just fall up into the sky. So you can kind of play around with that, change the direction of gravity in your game. Let's change that back. Back to negative 9.81. Okay, so now that we have this, Let's make sure that we're jumping as we wanted to again. We are not, because I edited that while it was running, and we want the mass to be 1. There we go. Got a decent jump again. There might be something that you've picked up on that's going to be a bit of a problem when we run the game. Namely, I can jump again when I'm in the air. I can jump infinitely. I guess some games have double jump, but you probably don't want infinite jumps. Maybe you do, but not in this case we don't. So somehow we need to be able to tell if we're currently allowed to jump. And the way we're going to do that is by detecting, are we currently standing on the ground? So let's give ourselves another variable to tell us if we're currently on the ground. And it's going to be a Boolean value called isGrounded. Just give it a note here. Track of players currently on the ground. And we're going to need to add into our update method here, okay, we don't want to only jump if the jump key's pressed. We want to jump if the jump key's pressed and the player is currently grounded. Well, we need to initialize this. So at the very start, let's just go ahead and say when the game starts running, yes, the player is on the ground. Technically speaking, they're not because I've placed them a little bit off, but you know what? Close enough. So now it should actually work exactly the same as before because I haven't changed anything else. But the other component we want to change is after we jump, we are no longer on the ground. Which should mean now, when I run it, I can jump once because we're grounded. But now no matter how many times I hit space, that is grounded has switched to false and it never switches back. How do we know when to switch it back? Well, one easy way to do it might be to say, hey, did we collide with anything? From lab 2, you probably remember that there's a method called onCollisionEnter. It's one of those predefined methods that all game objects have, and we can now implement and write the code to tell it how to act when it collides. So onCollisionEnter, when it hits the ground, we want to switch isGrounded back to true. We've hit the ground, we're back on the ground, we're allowed to jump again. There are other ways to do this, but this is, for the purposes of demonstration, a great way to handle this. So now I can jump again, and if I try to jump in the air, it only lets me jump when my player is currently standing on the ground because it's false. So isGrounded is true, false, hits the ground, now it's true again, and I can jump again. There is a problem with that. Namely, it's only detecting if we collided with anything, not necessarily the ground. So if we were running around an environment and we jumped, smashed our face into the wall, we'd be able to immediately jump again. If an enemy hit you while you were in the air, guess what? You've collided, you can now jump again. And we don't want that. We only want to jump if the thing that we're currently interacting with is the ground. In a lot of games, though, you don't necessarily know that there's going to be only one object that is the ground. So one thing I could do is I could check like, okay, is the thing I collided with this object that I've named floor? In our case, that would work fine, but that's not particularly useful if you've got some flat models and then you go onto a hill model and then you're walking on some stairs and you want to be able to jump no matter which one of those you're on. If it's a platform you can stand on, you want to be able to jump. What we're going to do in this case is we're going to use something called a tag. And up to this point, we haven't really messed with this field, but over in the inspector here, where you type in the name of your object, there's also been this tag dropdown. And it's got a couple predefined ones, but in our case, we're going to add a new tag. So if you click add tag, the list is empty because we haven't created any. So if I make a new one and I call it ground, it's descriptive. Now we have a tag called ground. And back on our floor, we can say, yes, this floor model does have the ground tag. So now we'll be able to detect if the thing we've hit has that tag. How do we do that? Well, we want it to be on our onCollisionEnter method. And the collision object that gets passed in here is actually a component that has a GameObject property attached to it, and this collision.GameObject points to the GameObject of whatever you collided with. So right now, if we've currently landed back on the floor, collision.GameObject is this floor object. It's whatever thing we hit. And GameObject has another method that we haven't used yet called compareTag. And what compareTag does is it checks to see if a string you give it is a tag that is applied to that object. So in this case, ground. So what this will do is, if the GameObject has the ground tag, this will return true. Otherwise, it'll return false. And what we actually want to do is we don't just want to call that. We want to say if the thing we collided with's GameObject has the tag ground, then we set is grounded to true. So it should still work as before. So that's working fine. But as a bit of a contrived example, now if I take this floor and I remove this tag from it and try again, fine. And now we can no longer jump again once we hit the floor because it detected a collision. It asked if the floor had the grounded tag, and it does not. So it never switched it back to is grounded. And that about covers it for the first half of this lab. The other component that I would typically have the students get a head start on now, you've all done this because we've already gone through this lab, but if you're someone else stumbling across this, is creating a spawner to create a bunch of hurdles that comes scrolling across the screen. In this case, the way we're implementing our infinite runner isn't to have the player moving, it's to have the background and the scenery and the obstacles moving at the player. So create a spawner that on a cadence spawns things that they have to jump over. Not going to cover that. I'll have that already set up by the time I go into the back half of the review for this lab. But I do want to go back and record a recap of the second lab of the semester. I'm kind of working in reverse order here. And that covers how to handle spawners and everything. So that's about it for the first half of Lab 3, and the second half of Lab 3 will be up next. Thanks for watching.